everyone, and welcome to your notes video on theoretical and experimental probability. So first things first, let's make sure we've got our name and our period circled at the top of our page, and we can dive right into probability. Okay? I'm sure you guys have heard about probability before. It's the likelihood that something's going to happen. So what's the probability that it will rain tomorrow? Or what's the probability that my favorite team will win? In math class, we are going to define probability as a fraction where the numerator is the number of favorable outcomes, or the number of ways you want something to happen, and our denominator is going to be the number of total possible outcomes. So what's the total number of ways something could happen? Now, there are two types of probability that we're going to talk about today, and they are theoretical probability, or probability in theory, and experimental probability, or probability based on experimentation. So let's start out with theoretical probability, which is on the left. Theoretical probability is the probability that an event will occur under ideal circumstances. Ideal, here we're talking about perfect. So if we lived in a perfect world, everything happened perfectly, what's the probability that that event would take place? Our characteristics of theoretical probability are what can happen. What can happen? So, the first time we're going to look at this is with two coins, much like these two dimes that I have here. They both have heads, they both have tails. If we were to flip these two coins, what could happen? Well, there are four different things that could happen. They could both land heads. The first one could land heads and the second one could land tails. The first one could land tails and the second one could land heads. Or finally, they could both land tails. No matter how many times you flip a coin, you will never get something that's not on this list. Okay? This is every combination that you could possibly get. So, if those are the four things we could possibly get, what's the probability of getting each one? A asks, what's the probability of getting heads on both coins? Well, we know probability starts as a fraction. We can look back up here if we've forgotten. On the bottom, in our denominator, we're going to want the number of total possible outcomes. Well, our chart shows us that there are four possible outcomes, four things that could happen. Now, on the numerator side of that fraction, we want the number of favorable outcomes. So, how many ways do we want it to happen? Well, we want it to be heads and heads. How many ways does that happen? Looks like only one. So, our probability would be 1 out of 4. Or, if we wanted to change that into a decimal, which you will often see, it would be 0 and 25 hundredths. Wonderful. Our second probability we're going to look at is the probability that the first coin is heads, but the second coin is tails. Remember that our denominator is the total number of things that could happen, and once again, it is 4. There are 4 different outcomes. How many of them are first coin heads and second coin tails? It looks like only one, this one right here. So our probability will once again be 1 out of 4, or 0 and 25 hundredths. Excellent. Moving on, we've got the probability that you will flip tails on the first coin and heads on the second coin. Our possible number of outcomes is still 4, and only one of them is first coin heads, second coin tails. I'm sorry, first coin tails, second coin heads. So our probability stays the same. Finally, what's the probability that we get 2 tails? Well, as I've said before, there are still only 4 possible outcomes, and only one of them is tails, tails. So that gives us a final probability of 1/4, or 0 and 25 hundredths. Excellent. Let's move on to another thing we can calculate with theoretical probability. The roll of a die, like this one. It's got 6 sides, and the numbers 1 through 6 are on each side. So, if we were to roll this die, or number cube, 6 times, hopefully we would get one number every time, and we would get the number 1, the number 2, the number 3, the number 4, the number 5, and the number 6. So each number would come up an equal number of times. Now, they might not come up in this order, 1, 2, 3, 4, 5, 6, but hopefully they would come up if it was a fair die. So let's see. In that case, what's the probability of rolling a 5? Well, there were 6 possible outcomes. 1, 2, 3, 4, 5, 6. But only one of them is a 5. So our probability would be 1/6 or 0.16 repeating. The next one's a bit trickier. What's the probability of rolling an even number? Well, there are still 6 numbers that we could roll, but how many of them are even? Nope. 2 is even, though. 4 is even, and 6 is even. So it looks like there are 3 even numbers for us to roll. That gives us a probability of 0 5/10 or 0 50/100, however you want to write it, which is also equal to 1/2. All right, let's move on. That's theoretical probability for you. Let's move on to experimental, which I actually like a bit better. Experimental probability is the probability based upon experimental data. So we're going to look at what has happened and try to predict what will happen. Experimental probability is what did happen. So, in order to calculate experimental probability, we need to figure out a couple experiments. Let's start flipping some coins. I have coin 1 and coin 2, and we're going to flip them and see what happens. All right, coin 1 landed tails, and coin 2 also landed tails, so let's record that. On our second try, let's see. Oh, they both landed heads. Coin 1 landed heads, and coin 2 landed heads. On our third try, we've got tails on coin 1 and heads on coin 2. And on our fourth try, we got 2 tails again. Tails on coin 1 and tails on coin 2. We're going to use these experiments to calculate our experimental probability down here. So, what was the experimental probability of flipping a heads and a heads? Well, we did 4 trials, so that's our denominator. We flipped 4 times. And let's see, it looks like just this one right here was heads and heads. So that's going to be 1 out of 4, or 0 25/100, which we've seen before. Let's move on to the probability of getting a heads and then a tails. Well, we did 4 experiments, but I don't think in any of them did we get a heads first and then a tails. It doesn't look like it. So our probability would be 0 out of 4, or 0. In C, they asked for the probability that we would get a tails and then a heads. Once again, we did 4 trials, and one of them turned out to be tails and then heads. So we've got a probability of 0 25/100. In part D, they want to know the probability that we flip 2 heads, 4 trials in the denominator, and lucky us, it looks like we got 2 heads twice in the first flip and on the last flip. So that's going to be 2 out of 4, or 0 50/100. Excellent. Now that we've finished our coin experiments, let's do some die experiments. So, I'm going to roll this die 6 times and see what numbers come up. Let's see. All right, looks like a 1 the first time, so that goes here. Our second time is a 4. Our third time is a 6. Our fourth time is a, 2. Our fifth time is a, looks like another 6. And our final time is another 2. So, our rolls were 1, 4, 6, 2, 6, and a 2. So, what's the experimental probability of rolling a 5? We did 6 trials, so that's our denominator, but none of them came up as a 5, so our probability would be 0. Now, what's the probability of rolling an even number? We did 6 trials, and let's see. No, oh, that's even. That's an even number. That's an even number. Oh my goodness. A lot of even numbers here. Looks like 5 out of our 6 trials were even numbers, which gives us an experimental probability of 5 out of 6, or 0.83 repeating. So, there's our experimental and theoretical probabilities. What you might notice is that they were different. Okay? Theoretically, we should have rolled all these different numbers, but we didn't. We only ended up rolling 1s, 4s, 2s, and 6s. So what happened? Well, if you read this little piece down here, it'll explain. The more trials you have, the closer your experimental probabilities should get to the theoretical probability. What that's saying is, I only rolled 6 times. And so my probabilities were pretty far off from each other, if you look. But if I had rolled, say, 100 times, or even 1,000 times, these probabilities would start to get much, much closer. So that's all for us today. I hope you enjoyed our notes video, and you can now talk to your teacher about what's next.